Let's get straight into it. We've all got it, haven't we? That one folder or that drive is absolutely stuffed with PDFs, reports, and all sorts of notes packed with really valuable information. The only issue is it's all locked away. You can't just talk to it. Or can you? Honestly, just think about it for a moment. Instead of wasting ages scrolling and using Control F to hunt for keywords, what if you could just ask that 1,000-page technical manual, hey, what's the talk specification for this particular part? Or maybe ask your meeting notes, remind me, what were the final action items from our Q3 planning session? Well, this isn't science fiction anymore. It's actually a really powerful AI technique that's completely changing the way we interact with our own private data. And today, we're going to break down exactly how all of this works, step by step. The secret ingredient here is a process called Retrieval-Augmented Generation, or simply RAG for short. Don't let that fancy name scare you off. It really just comes down to a pretty simple two-phase process. First, we teach an AI everything it needs to know from our documents. Then, we get to have a conversation with it. Think of the first phase as building a specialized brain or perhaps a super smart digital library using nothing but your own documents as the books. We're not just dumping them on a shelf, we're carefully organizing everything so the AI can find exactly what it needs in an instant. This process has four key steps. First, we load the data, pulling in all those PDFs, web pages, and different files. Then, we split them up. We can't give a 1,000-page document to an AI all at once, so we break it down into smaller, bite-sized chunks, a bit like paragraphs. Next, we embed these chunks, and this is where the magic happens. We convert the text into numbers. Finally, we store these numerical representations in a special database called a vector store. Splitting is necessary because every large language model has something called a context size limitation. It's short-term memory. It can only focus on a certain amount of information at any one time. By breaking documents into smaller chunks, we make sure we can feed it only the most relevant parts without overwhelming it. By the way, consider subscribing. Embedding is the most abstract but also the most brilliant step. This is literally how we teach a machine to understand the meaning and context of your words, not just the words themselves. A computer doesn't understand words like apple or database the way we do, but it's a genius with numbers. The embedding process converts the meaning of a phrase into a unique numerical address, a vector. This allows the AI to do mathematics on meaning itself. So phrases like vector stored database and database for storing embeddings end up with very similar numerical addresses, helping the AI find related concepts. Pretty cool, isn't it? Once we've built the AI's brain and filled up our smart library, the hard work is done. Now comes the fun part. We actually get to ask our superpowered librarian a question. For example, a user types, "What is a vector stored database?" Behind the scenes, the system converts the question into its own vector. Then the retriever zips over to the vector database and says, "Find me the text chunks whose vectors are mathematically closest to this question vector." Instantly, it pulls out the most relevant paragraphs from the original documents. The large language model doesn't just get the raw question, it gets a carefully prepared package. The user's query, instructions like "You are an expert AI researcher," and the text snippets retrieved. This ensures the AI's answer stays grounded in the facts from your documents. The final response is natural and conversational, but crucially framed with transparency, based on the provided context. That way, you know it's reasoning solely from your documents, not general training data. This prevents mistakes and ensures accuracy. By the way, leave a comment if you have any questions. So we've just walked through the entire process, from a raw PDF all the way to a smart, accurate answer. You might be thinking, this sounds complicated to build. But here's the good news. Frameworks like LangChain provide all the tools you need, almost like a complete toolbox for building your own RAG system. You have loaders to bring the data in, splitters to break everything up, embedding models to convert text into numbers, vector stores to save and search those numbers, and retrieval chains to handle the process of taking a user's query and providing the right context to the LLM. Each part has its own clear role to play. Why does this matter? Because RAG marks a fundamental shift in how we build and use AI. Loading, splitting, embedding, storing, and retrieving. That's the blueprint for building powerful, personalized AI tools rooted in your own data. It's how you give a general purpose AI a specialized, expert level education in literally any subject you want. We've pulled back the curtain on how you can make your documents speak. The technology is already here, the pattern is clear, and that leaves us with one last, truly exciting question. What conversations are just waiting to happen with your data? Thanks for watching, and don't forget to subscribe for more interesting tech topics. Also, check out other videos.